Hello, and welcome to another episode of Pardon the Dust, Dusting Off Construction with Caitlin and Jillian. We're your hosts, Caitlin
and Jillian.
And we're here dusting off the topic of being an architect with an interest in using the newest technologies with Avinash Verma, design technologist from CBT Architects. So let's get to it. Avinash, could you please introduce yourself and CBT Architects?
Hi, so my name is Avinash Verma, as you said earlier. I work at CBT Architects. It's been about a year and a half in total, like including my internship and my full-time job. And I work as a design technologist. So some people don't really know what design technology is. It's uh, it's a midway role between being an IT developer and an architect. So it's kind of best of both worlds,
That is
and
very cool.
that kind of fits straight into what I wanted because I was trained as an architect all throughout. Like I have an undergrad in architecture, then a grad school in architecture. So 7 years of that, but at the same time, I had some of my own hobbies and some personal work that I would do in the development and coding world. So this was like the perfect mix for me to pursue. And yeah, I was lucky enough that that CBD was kind of hiring someone for exactly that role when I was applying for it. So that helped out
I was
perfectly.
going to say, it sounds like exactly the role built for you, exactly.
Yeah, a match made in heaven. Yeah.
Absolutely.
That's awesome. So you said that you did 7 years is that schooling to become an architect?
Yes, in India, the undergrad architecture program are 5 years of undergrad architecture. So you come out of those 5 years and you're a licensed architect in India. So like in the States, you have to give an examination. We don't have that in India, so it's a 5-year program. And then I worked there for a year and a half, and there was COVID times as well. So a year was just gone away doing nothing.
Yep.
And then
Yeah.
I moved to the States in 2021 to join my grad school at University of Illinois. So 2 years there, and then I joined CBT for a full-time job position. Yeah.
Wow. So you've been doing it for a long time. What's your favorite part about being an architect and about everything you've learned?
So my favorite part has, I think, changed over the past few years because during undergrad, when I joined in, I had no idea what architecture was. It was just, uh, thanks to the education system we have, we kind of choose our fields of interest without knowing much about them. At least in India, I don't know how that works in the States yet. But so I didn't know much about architecture, but I knew like, okay, it's an artistic, it's a creative field. It gives you a good output for all your creative endeavors, and that's how I picked it up. And not until third year of my undergrad when I actually felt the passion for architecture in general. Like that's when it started to pick up. Like, okay, this is something I want to do. This is something I want to do. And the best part about being architect back then was just being very creative and very unhinged in the terms of what you design, what you think, and just learning new ways to implement stuff. So that was the first part of why I liked architecture. And when I moved to the States, I met like my worldview about architecture completely changed because the way we practice architecture in India or in the Southeast Asian region or Southern Asian region is very different from what the practice is in the United States, in terms of what tools we use, in terms of what the deliverables are, or even in terms of how we think about design. So that was a very completely new avenue for me. And I was fortunate enough to meet a few really influential professors who like pushed me towards the competition design path because for me, I didn't know that there was any merge possible of these two fields. It was just a hobby for me. But the moment I got to know about that, that's when it clicked that, okay, architecture is not just about doing one thing, but architecture gives you like a very open scope to follow more stuff because you basically train in a lot of things in undergrad of architecture. I feel it's one of the most diverse teaching experiences or learning experiences you have. From first
Yeah.
to fifth year, you go through almost everything you can think of. And that kind of plays well if you have a very open mindset regarding what you want to work in.
Yeah.
And once I graduated and I had a job here at CBT, I kind of fixated on the competition part of it. But at the same time, I still love architecture. Like ArcDaily is still one of my favorite websites to visit, just to see what other people are doing, what's the most innovative design trend happening right now. But at the same time, to know the technicalities of the industry and to work on those technicalities to kind of push the boundaries, that's more something up my alley. And that's something that I actually like right now, being an architect and also not being an architect at the same time. But yeah, that's something that I actually enjoy.
That's awesome. So you use a lot of technologies in your work now as you've progressed past this like going wild and doing this very artistic architecture and more into the technical side. What are your favorite technologies that you get to use, or what technologies do you want to use in the future?
Hmm. Um, So again, it's two answers. One, during when you're a student, you have a different idea of what technologies are good, and then when you're actually working, it's completely different.
Yep.
Because as students,
Absolutely.
the only idea we had about technology would be like the latest rendering software
Yep.
or the latest presentation software. And I'm pretty surprised, like in today's world with all the AI advancements and your uh, computer generated images, how has that affected work, like student life? I have no idea, but I'm pretty sure if I was right now studying architecture, I would have completely different sets of tools I'll be using. So back in school, my most common tools were Rhino and Grasshopper. And Grasshopper was actually the main um, software that kind of pushed me towards the computation side because it's a visual coding software. You kind of build your three-dimensional objects based on some form of code. You don't actually code in it. So it's a bit user-friendly, and it's a good intro to parametric modeling, construction, detailing, and stuff. So that was my favorite tool back then. And today, I would still say it's that. But addition to that, it's we in-house build a lot of custom plugins for Revit. So kind of working on more customized aspects. It's not a technology per se, but more of a workflow that I like now.
Yeah.
It's mostly about customization. Like any software we use, any product we use, what's the scope of customization? Because at the end of the day, each firm has a different workflow, each firm has a different target they want to achieve. And most of the times, the tools that we have do not completely satisfy what we need. So just being there and having the skills or having the ability to make custom solutions for our architects and designers, that's what I actually enjoy right now. That's the part of technology I enjoy,
Right.
customization.
So, what goes into actually like creating those?
Um, so if I were to pick an example, let's say, we can actually take an example, Revit, Grasshopper, or Rhino. All of these have a very strong backend API. These are the well-documented codes on which the whole software was built up, and and these organizations have put them out public for us, people who are involved in developing, to use them to create new tools. It's like saying, okay, this is how we built our tool. Now I'm giving you all this tool set. Now you add on to this tool. So that part of addition is what I'm doing, and all of this is very readily available online. But you do struggle with kind of sources to learn because this whole field of customization and architecture is pretty new. I don't think it dates back more than 10, 15 years, and that's still a very small time in terms of documentation of how to do stuff. So
Absolutely.
finding documentation was one of the biggest challenges I had to see actually, okay, how are people doing it? How would I go about if I face a problem? So that's been challenging. But I think at the same time, just because AI is so good right now, like ChatGPT is one of the best assistants one can have. And I literally have it open all the time as a second assistant to ask it questions. Okay, I'm
Yeah.
stuck here, help me out. Stuck here, help me out. And
That
so
makes
that
sense.
helps. Yeah.
Absolutely.
So, if finding the information was one of the most challenging and continues to be one of the most challenging things for you, I imagine
Hmm.
that's also one of the most challenging things for other people in a similar situation for you. Do you have any
Yes.
tips for them on what you found that works or kinds of combinations of things that you throw together and see if it fits?
It's a bit of both. So I did get a few resources in the beginning where people kind of handhold you throughout the process of setting up your environment of how would you start making customized solutions. So it's an effort to go through all those. They're like 6 or 7 hours single stretch videos um, of a conference happening in New York. So let's say the one I really remember is an AEC hackathon, and I
I
think
love
the
hackathons.
yeah, the organization's name is Bad Monkeys. I can share the link later on after we end this podcast. Bad Monkeys, and they had a huge video of like 5, 6 hour long video, and that's like one of my, I would say, bibles from where I learned how to customize for Revit. And similarly, there are a few videos like that for each software you would know of, but you won't get complete information from them. So you have to take that and then do your own research. Go to forums, go to community pages where people are talking about similar problems, because you're not the only one. There are people who are doing this, who are facing the same problems. So the more you look at people working on what they're doing, the more you learn. And it's mostly trial and error. Like even if I get a piece of code that I can just copy paste into my program, it still won't work until I know how it's going to work or what I need it to do. So it's mostly trial and error and just trying to find as many resources as possible. YouTube is your best friend. YouTube is basically a free university, and almost all the people involved in this part of AEC industry put videos on YouTube. Even I'm planning to do that in the future because I know there's a lack of documentation and I can help with it. And others who have this knowledge have been adding on to this documentation. So it's a cumulative effort everybody's trying to do. But yes, we have a long way to go to actually call it a very fledging and I don't know, very forward-looking industry. Right now, we're all very isolated in our bubbles.
Yeah, I was actually going to ask you if you're going to consider creating any documentation or any like assist, like the YouTube videos, as you had mentioned, in order to continue to help others learn and find information, because the collective effort is what we need.
Yeah, I could add on to the previous thing as well. Like I did think about adding like my input into the documentation of all this stuff, like by videos or Medium articles or LinkedIn posts. But at the moment, I still feel like a little bit of an imposter syndrome, as in I have learned things off the internet. I haven't had a person above me who knew more about this than me to teach me these things. So it's more like I might be wrong in a lot of things that I do. They're just working out for me.
Maybe
I don't
it's
want,
luck. Maybe it's
yeah. I don't want to
correctness.
preach. I don't want to preach something out there in public that might not be true. So I'm
Yeah,
still waiting on getting more validation on my work to
makes
start
sense.
actually putting it out there for people to use.
Yeah. So as you know, there's been a lot of technological advancements within the past 10 years, just simply. And what do you foresee for the next 10 years from now? Like, what's the future growth in some of this technology? Where do you see it going?
I think it's more about people adopting the technologies. Like these technologies always existed. As long as these softwares were out there were ways of modifying those softwares. There were ways of adding to those softwares, but people didn't really adopt those practices yet. Now it's like you see an inflection in the curve of adoption that, okay, people have started to adopt. And as more people come into the industry of merging the tech and architecture side of it, the more I would say um, it would become common for firms to have teams that are doing this, because right now it's a very niche role and you have to really look for, if I was looking for a job right now, it would take me weeks to find places that have similar job roles or similar ideas of teams working in, or teams big enough to implement something on a scale. So it's mostly about adoption. And I think as soon as this kind of seeps into our educational background as well, into our grad school courses, it's going to help a lot, because students would know about these things while they're in school rather than coming out of school. That's how I got in as well. Like one of my professors told me, okay, there's something called computational design, there's something called design technology, you should go for it. And that's when I knew about this thing. And if I had more courses about this, maybe back in undergrad, I would be more informed coming in. So it's all about people knowing, and like we're talking about it right now. And I haven't heard a podcast talking about this topic in a long time. So even this adds to the information spread that, okay, something like this exists, this is a new avenue for people to try.
Yeah.
So I think that's how these technologies are going to affect us, because we have to start adopting, and more people adopt, the better we know what we can use these technologies for.
Yeah, another thing I had heard last year, I was at a marketing conference, and a lot of the talk was, of course, about AI. And they were just talking about how early adopters of, not necessarily just AI, but early adopters of technology and new technologies are always going to become the experts in the future. So I'm sure that feels pretty cool for you, being one of, kind of being one of the early adopters and becoming an expert now. So that, within those next 10 years, when people are just onboarding, you're super seasoned and you've been here and you've helped, grow this type of niche in the industry, which is very cool.
This is one effort. I actually feel like I am an early entrant.
Yeah.
But not exactly early, but for me, it still feels early. Like you missed all the dot-com bubble. You missed time to make money in the stock market. But at least I did not miss this. That's how I feel right now.
It's a good perspective to have.
Yeah. Right place, right time for the right thing.
Yeah, exactly.
So I wanted to shift gears a little bit. I know you had shared with us previously about a design competition that you've entered while you were at school. Do you want to elaborate a little bit on that project? Because it was very cool reading, and I'm excited to ask you more questions about it.
Yes. So our professor in grad school, Professor Nilüfer Emami, she has her research in precast, uh, not precast, but like concrete modules.
Hmm.
I I I always it's tough for me to explain her research because it's very vast.
Hmm.
So what our studio program was, we had to develop modules that were topologically interlocking. So what that term means is you don't need a mortar or you don't need any binding material to like stick these two modules together. The way the geometry is, they're going to interlock. That was the whole idea about it. And the reason why we're doing that was our particular concept was to send these prototypes into places where we have issues with construction, where there are maybe monetary issues or issues with actually taking having your materials reach the site. So you can maybe build pretty quickly because you don't need mortar. You can just 3D print your formwork and pour concrete, which even laymen can do. You don't need a specialized personnel to pour concrete in smaller places. So something like that was the idea. And the whole topologically interlocking was to make it quick as possible, as cheap as possible, and as scalable as possible. Because what our modules were, it was a single module, and you could just replicate it n number of times, and you just keep scaling it. You don't need special pieces for like corners or stuff. So that was the whole idea, and the development took almost a whole semester. That was the whole
Wow.
design period. We started off with like maybe a 4 inch or 3 inch smaller sizes of modules in the initially, and just by hand casted them, like you literally pour them out of a mug, like the concrete, to the point where we actually took like a real 1:1 scale piece. We were mixing them in buckets with mixers, with retardants, and actually having to cast each individually because it takes time. So it was a huge experience for us, and I think it was the first time I was actually working with concrete with my hands, especially because you always design stuff on your software, but you never get to implement them in real life. So you don't know
Yeah.
that part of the effort that goes into creating something. So that was a very good experience. And so post our studio ended, we applied to a few competitions, one of them being Sara National Design Award in the student category. And so yeah, we won that award, and it was good to be appreciated for your hard work. But it was a fun experience because it's something completely new and something really innovative what we were presented in the studio as a brief to do.
Yeah, like I said, it was super cool. I went to school for industrial design, so I did product design. So like it kind of just spun back my own thoughts and memories of making models and prototypes and like creating real things.
Yeah.
So that was very exciting. I know you had also 3D printed your formworks for those. Do
Mhm.
you want to kind of chat about your 3D printed or 3D printing experience and
Yep.
coming up with that?
Yeah, so initially the first prototypes that we created were really small 3D prints directly, like the whole piece was a 3D printed piece,
Mhm.
just to test out whether they actually work, whether the interlocking works. Because once you design in the software and think that the physics is going to work out, but actually we don't have really good understanding of how the physics work. So when you actually print them out, put them together, you realize, oh, it's slipping off somewhere. It's not holding it together. So that's when you start building up, and it's cheaper to just print in 3D in small pieces in bulk and then test out your prototypes as in you go. So we've made 10 to 12 prototypes for shapes, different ideas of interlocking, different ways of interlocking until we stumble on a puzzle piece. Like, okay, why don't we use a puzzle piece? Because we always use puzzles. It's always fun to do puzzles, and puzzles interlock inherently. They have a um, let me start that again. Puzzles inherently have a skill. Okay, I'm at lost for words. Just a
They're kind
second.
of they
Let
have
me
like a hook
gather.
to them.
Yeah,
Like they I mean they
they
interlock
have
for
this
sure.
property of just interlocking, right? So you're
Yeah.
like, that's 2D, let's just translate into 3D, and that's when we start off. And so the idea about creating those surfaces was we'll create an external formwork in 3D print because it's quicker and you can just have very accurate edges to it, and then pour our concrete in it. And also the idea was when you send this file out, so the end result would be we'll send a 3D print file on site, and we'll have 3D printers on site. So you just have to send a code into the machine. It's going to 3D print all your formwork. Someone on the site can pour the concrete, and your formwork is ready. So there's no transferring heavy materials or heavy precast objects, which would also be good. But at the same time, concrete blocks are heavy.
Yes.
So
Yes.
to reach these places, the most efficient way was to just have your raw materials there and then just cast it. Minimize as many logistical problems as possible because these spaces already have a lot of other issues that they have to tackle to also add on to logistics. So there was like just easing all efforts in making those modules. And so we 3D printed the casts, and a lot of time went into designing those casts because we don't really understand how casts work unless you actually make one and
Uh-huh.
try to assemble one. Because assembling casts is a big headache. You'd never know if it's
Mhm.
coming off or not. Is it airtight enough to hold the concrete in? So all these challenges keep adding up, and we had to iterate over casts as well until we reached a place where we're like, okay, this is good enough, and we should go ahead with it.
Yeah, that makes sense. So you said you printed some of your prototypes. How many do you think you ended up printing?
We initially had 8 unique design options, and for eight each of them to actually portray how they interlock, you have to print 5 or 6 pieces each to kind of show the whole accumulation of those pieces. So I would say like 35 to 40 pieces for just the initial prototyping stage. That's when
Wow.
we chose 2 out of them and then went forward with creating smaller casts, like palm-sized casts,
Uh-huh.
to pour concrete in and test the prototypes out in concrete, and then go forward with thinking, okay, what's the most efficient now? Because we had another design that was really aesthetically pleasing. It was more into a flower shape, but the making the cast was so difficult,
Uh-huh.
and removing the cast, we had to burn out the plastic of the 3D print, so that was not
Mm.
efficient. So we
Yeah.
had to discard that idea, even though it was the most aesthetically pleasing idea. I would
Uh-huh.
have loved to go forward with that idea, but it's just impractical with that cast.
Yeah.
So we chose the other idea, and that's how we went from that scale. Then we increased the scale to like 2:1, and then we finally went to 1:1. So yeah.
Very fun. How many final
How
pieces?
many final pieces? Yeah,
Yeah,
the initial idea was pretty ambitious to actually build,
a whole
let's say, a
little.
2 feet by 1 feet wall. Still
Mhm.
not
Wow.
big, but still, it was a huge idea.
Yeah.
But the moment we casted the first piece, even though we had some hollow pieces, it was very heavy. And the
Sure.
moment that came out, we knew we don't have first enough resources to print them because 3D printing gets expensive on
Oh
that
yes, yes.
large scale, and we're not subsidized. We're at university. We barely got a few $1,000s to the whole studio just to buy materials. So it was not covering up everything. So it was getting expensive. It was getting heavy, and we didn't have enough time towards the final review. So we just ended up making, I think, 8 to 9 full-scale pieces, enough to demonstrate interlocking and special abilities. Like there was once where you can remove one piece from the middle and still the it was like a hole inside the wall and it still worked. So we
Very
That's
wanted to
cool.
really cool.
demonstrate that. So we need 5 or 6 pieces for that.
Yep.
We made about 8 pieces, different textures, different openings. One was a solid piece just to make sure, like if you need a privacy wall, you could use that. So to demonstrate all our options. So we did 8 pieces, 8 to 10 pieces, if I'm not wrong. Yeah.
That's very
That's
cool.
cool. Where do you, so obviously this was created in university for a thought experiment, but
Yep.
where do you see this actually being applied? Maybe not your specific idea and design, but
Mhm.
this kind of thing, what would it be applicable for?
Um, Again, I think I mentioned this earlier. It was all about their places, like in a lot of places in India where you have challenges with capital and challenges with raw materials reaching that site, and also challenges with specialized labor. You don't
Mm.
have people who are skilled enough to do this job to maybe cast a complete concrete wall or make a whole building. For those places, these solutions come in handy because you don't need any skills. You would just need a few devices on site and concrete. We also had a thought experiment about just using mud, but we didn't
Hmm.
experiment that in grad school. That would completely remove all of our raw material. Just the 3D printing and the 3D printing filament would be left out. So something on those terms that we could localize construction as much as possible. I know this goes against precast as an idea, but this was precast, but in situ casting. I mean, it's weird how we went into this avenue of casting concrete because each group had a different idea how it would be delivered. A lot of people
Uh-huh.
had it built somewhere else in bigger cities and delivered them on site. That's like a very normal precast procedure. For us, it was more, we'll send our devices on site. Our 3D printers will be on site. We'll send the code, print out the cast, and build it. So it's helpful for places where you need to very rapidly build up a wall. Let's say emergency housing. Like if
Yeah.
there's a tornado affected somewhere, now you've dislocated. A lot of people have been dislocated from their houses and then in temporary housings. There to build something up quick, fast, and something that can be removed and assembled again. That's the whole idea for our modules were.
That's
Yeah,
awesome.
definitely a lot more portable.
Yeah,
Yep.
and it's almost like you're making a little precast plant on the site.
Exactly.
And obviously,
Exactly.
it's not really a precast plant.
Yep.
To all our
Yep.
precast listeners, I understand there's a lot more that
Yeah.
goes
Yeah.
into it. But it's almost this portable precast plant for limited materials, limited availability, limited funding, but we need to
Yep.
get something up because people need a place to exist.
Yep.
It's really cool.
So with your project as well, like, what would you say the most like interesting comment you had received on this project?
Interesting comment. The first one again was the weight. Even our reviewers, one of our reviewers wanted to just pick up a piece and see how heavy it was, and then we warned her, and she picked it up, and it slipped from her hand and dropped down, and it was like, okay, so it's heavy. That was the first comment I remember clearly, and it was a fun comment because throughout the build process, we never thought about doing actually weighing them in. I don't know why we didn't. We weighed the concrete we poured in, we weighed the water, and we were like, okay, we just add them up, and that's the number. We should have actually just weighed one whole piece just to have a number to it, but that one was a big one. And the second one was that uh, we had a corner piece in it, and someone said like, okay, that looks like a puzzle piece. I'm like, wait a second, don't you see the everything looks like a puzzle piece? We made it based on the idea of a puzzle piece. So yeah, I mean, apart from that, most of the comments were regarding your solar and your climate analysis, because we had cavities in our modules. We had holes in the middle of our modules, so it was very uh, good for places where you need the wind to come in and not the sun. So that was an important design aspect, which people appreciated in our reviews as well.
Yeah, I mean, definitely looking at them, they don't look like they would be heavy per se.
Yep.
But I can definitely see why they would. Obviously, they do. That has been tested. But
Yeah.
they don't seem like they'd be as heavy
Yeah,
as they
that's why
seem like they
we
are.
created multiple options. The heaviest one was obviously the solid one, which had no openings in it.
Right.
But the lightest one we created was a very thin, kind of a shell kind of exterior for the concrete, and that was pretty light. And that's what our main module would be in actual use if it were to ever get used. That would be the main piece, because you could pick them up by like one hand and just keep assembling. That was the most efficient of all.
Yeah. What's like something that you learned from doing this project that you kind of still use today and actually working? Are there any like concepts that you learned during that process that you still kind of use today?
Not really, but I think the biggest learning was making multiple prototypes. We kind of tend to limit ourselves with the ideas we have. We think, okay, we list down 3 ideas and like, okay, that's good enough. Let me start working on each and see how to go forward. I would say the more ideas you have, you should just dedicate 1 week when you start a new project. Just build up ideas. Don't think about how feasible those ideas are. Don't think about how efficient those ideas are. Just build out ideas for a week, and you'll have a good set of um, a good base to get off from, and you can easily pick up things that are good for one situation, bad for one situation, mix them up together. Because if you don't have multiple ideas to start with, you'll always struggle with problems in the future.
Yeah.
So just bring your ideas out before starting a project, and then go from it. As many prototypes as possible, but do limit yourself to the time. You can just keep building out prototypes. So give yourself a week, or depending on whatever timeline you have, give yourself some time. Just create ideas. Don't think about practicality.
Yeah, that's a big thing for me as well. I always need to make sure if somebody's only going to present me 1 to 2 ideas, and like give me more.
Yep.
So that you can now prove why these first 2 you did show me are the right ones. Or now you found 2 more ideas that actually are better than your first 2 ideas. So the more ideas, the better, or else you're never going to really know if your first idea was a good idea.
Yeah, because whenever we have less ideas, we kind of tend to make them more practical, because we know these are the only options we have. If you have more ideas, you generate more creative solutions. They might be inefficient, but you still have a few points from that particular prototype that you can use in your main final prototype. So you have more ideas to harvest from. It's always better.
Yeah.
Yeah, and I feel like that's kind of what makes us as humans unique and special is the fact that we have creative solutions and ideas, even though
Yep.
they might be completely unfeasible and
Mm-hmm.
they might turn physics on its head. We
Yep.
still have these creative ideas, which I think is something that AI is an extremely long way away from replacing. So
Yep.
I fully agree, and I think everyone should take that piece of advice and that lesson that you learned to work because it's something that everyone can apply in their work. Be creative, don't limit yourself at first, and then go back and see what's feasible. But don't worry about that at first.
I mean, I've gone as far as using that for my everyday life as well. Like whenever I have a problem and I'm thinking about what to do, just like list out whatever options you have, as many as you can. If you have something new to think about that as well, and then go forward with it. It gives you a good base to start from. So yeah.
Yeah. And even like making sure you don't limit your ideas to any
Exactly.
constraints, start with the whatever, everything's possible. What would be all of your options? And then you can look at them to say, yeah, I can't do that with the resources I have, or be able to convert that idea with no resources to fit into the fact that you only have a constraint resource allotment. So that's always a very important thing to think about as well. Never limit yourself.
Yes.
So another kind of switching gears a little bit, kind of back to technology and just how do you continue learning new technologies and implementing these new technologies?
I have a fear that I don't want to be left out. So it always feels like because there's so much out there. If you go on LinkedIn and you see other people what are they working on or what are they posting, you always feel like, okay, there's so much more out there to learn. And as far as you have that fire or you have that hunger in you to be curious about things, you'll learn. There's no shortcut to it. You have to be curious. I can give you 100 YouTube videos. I can tell you, okay, there's a course on Udemy, there's a course on LinkedIn Learning, go do that. Even if you do that course and you're not curious enough of what that does, you'll never learn. You'll never want to learn. So I think at the base of it, you have to be curious.
Yeah.
You come into work 9 to 5. You cannot limit yourself by saying, okay, this is my task that I've been told before joining the firm, that this is my job role. Anything outside this job role, I'm not comfortable doing. If you have a mindset like that, you won't be learning much at that job. So be open to new work, be open to taking up new challenges, even if they're very tough. But if you don't take the challenges, you're never going to face them, you're never going to overcome them. So be curious, be open to new stuff. That's how I go about learning things.
Yeah, that makes sense. Another question I'd love to ask is if somebody else was interested in exactly what you do, as you do now, since it is kind of still in its infancy phase.
Yep.
How would you what would you recommend they do in order to get a role like yours?
First of all, there will be a few technical skills that you would need in your bag. Would be you could pick any programming language, most probably just pick up Python because it's the easiest to learn for new beginners, and get up to speed with that and kind of learn how you can bring in your programming language into the architecture world. That's where you could either use it in Grasshopper with parametric modeling or in other softwares and creating something custom. You don't need to know it completely to get a job because I think right now these job roles also know that it's better to have a person who has some information, some knowledge, and wants to learn rather than finding or looking for a person who knows everything about this field and just help us make something up. Because we don't have enough people like that right now. The people who know everything, who are experts at this field, have got really good jobs. They're well established. They're not going to leave that, or they have their own businesses, their own consultancies that do exactly the same thing. So being a person who's curious and being a person who has some information, get up to speed with some languages, pick up a language, do it, go through with it, and start applying. Just apply to places where you see job roles, or talk to people on LinkedIn, text me, message me whenever you want, whatever. But just try to put yourself out there. Tell people that you know these skills, you have these skills. Unless you do that, you won't get any opportunities.
That's awesome. And even circling back to before when you said how you learned things, it was really through a community. It sounds like the community of people in the overlap between architecture and development is really growing and personal right now. Would you say that that's true?
It is, and recently, I met Jillian at DEF CON as well. That's where we met. That's where the whole idea of this
Yeah.
Okay.
podcast that started from me being a part of the podcast. But DEF CON was an amazing experience for me because that was the first time I met people who are doing the same job as I am doing in a social public setting. Because before that, it was mostly online, on forums, or in someone's Reddit name. I don't even know that person. So it was good to put faces to those people and to actually see that, okay, they have the same problems, they're also looking for solutions, and I can see how hungry they are to find solutions and learn more things. So that motivates you and that pushes you more, and you always find people who are doing way better than you, and it's always good to find those people, because
Okay.
unless if you keep finding people who are not uh, better than you're not going to improve. You won't have any motivation to improve. So it's good to put yourself out there, meet people, or talk to people on forums as well. Do as much as you can to network with people doing similar job roles.
Yeah, that's awesome advice. And for those of you listening, DEF CON, or more specifically DEF CON X, was hosted in Boston this year by Autodesk. And so that's a development conference for any people who are interested in developing their software using Autodesk products, which hopefully
Yep.
Autodesk is a familiar name to all of the people listening.
Yeah, and
Just for a little bit of context there.
and I would say it's a very golden time to get into this, because Autodesk itself realizes that this is a very good future, and they're pushing their development side as the most I've ever seen in the past few years. DevCon X has become one of their forerunners after AU, and
Yes.
we've had multiple DevCons. One in Boston. 2 weeks later, there was a DevCon in Munich. There's two
Yes.
hackathons and DevCons back to back. There was one in September last year in San Francisco. So they're pushing for it, and we as customers and people in this industry need to realize that if the biggest company in our landscape is pushing for something, which means there's future in it. So yeah.
Absolutely. And I want to just say, for anyone listening who might be interested in getting started, there are a lot of low code or no code options. So if it's the software engineering side of things that's scaring you off, there are tons of resources being created with you specifically in mind to get into this field.
Very good. I know I don't have any other further questions. I think we asked you such great questions and you gave such amazing answers. So, Jillian, do you have any other questions?
I don't. I feel like that's a great place to wrap up, with just getting a warm feeling about the community that you're a part of. And thank you for all of your answers and questions about architecture and also software development in the field.
Oh, thank you so much. It was fun being part of it. It was my first podcast I've ever been on, and I was really excited for it, and it didn't let me down. Thank you.
Yeah, that's awesome.
That's our goal. We want to make everybody comfortable and excited.
Absolutely.
Yeah. I'm going to share this with all my family, friends, and colleagues. Please see, I talked it somewhere. I was talking somewhere. Please see.
All right. Well, I'm going to wrap up here. So once again, thank you, Avinash, for being here today and speaking with us about everything that we talked about. And thank you, listeners, for your time today. You can find our next episode wherever you prefer to listen to your podcasts. Spotify is coming soon. And of course, be sure to follow us on social media and to get some, all the latest and greatest updates about our next episode release, a tease to our next guest potentially, and the next topic, and more. So we hope you like the show, and you'll hear us next time. Thank you.